All right. Simplifying rational expressions. So we're going to learn to simplify a rational expression and understand that we're finding an equivalent expression that's just in simpler form, okay? We're learning to find the restrictions on the variables in the denominator of a rational expression. So what makes this different from yesterday is we're not looking at rational functions that have a graph. We're just looking at rational expressions, okay? So they don't have a graph to worry about, but they do have more than one variable in many cases, okay? Which makes it a little trickier to wrap your head around the restricted values, but we will make sure everyone's good by the end of the lesson. And then also understanding the difference between rational functions, which is what you did yesterday, and rational expressions. So a rational expression is simply defined to be two polynomials being divided, okay? Ratio means division. So here's three examples of rational expressions. There's one, probably looks the most familiar, but it's missing the f at x equals, or the y equals, okay? There's one that does not look like something we saw yesterday, okay? It's got m's and n's in it. And here's one that's got x, a, and b in it, okay? So rational expressions are different. You don't have a graph that goes with them. They're just expressions on their own, okay? So keeping in mind that even with rational expressions, you can never divide by zero, okay? For each rational expression above, determine the necessary restriction or restrictions on the variables. Okay, so we'll do them one at a time. We're going to start with this one. And all we're focusing on here is the restrictions on the variables. We don't call it a domain anymore because domain goes with graph. These ones don't have a graph. Okay, so we're just looking for restricted values only. We don't have to ever add on that. X could be any other real number. So similar to yesterday, except we don't have an f at x equals, so we have to make our own equal sign, showing logically equivalent steps here. We would look and see if we could factor in the numerator. No, we can't. There's no common factor. It's not a difference of squares. Can we factor in the denominator? Yes. Difference of squares alarm bells going off in your mind, hopefully? Yes. And if not, is there a common factor? No. Count the terms. 2. Is it a difference of squares? Yes. 2 perfect squares separated by a minus. So this factors to give me x plus 3 times x minus 3. Which again, if you didn't catch this yesterday, now it's a product. So it was a subtraction, now it's a product. Okay? Yep.
Does it matter which way you do it? Like the
whether you get the minus? No, not at all. That does not matter. Okay? The reason is because multiplication is associative. So it doesn't matter whether you do 2 times 3 or 3 times 2, you're still going to get 6. Okay? And all of these is two different numbers that look more complicated because we've got an x with them, x plus 3. Okay? So again, you can't divide by 0. So for this number, x plus 3, to end up being 0, the only value of x that would make it 0 would be negative 3. Does everyone see that? And for this number, unknown number, x minus 3, to be 0, the only value of x that would make that true would be positive 3. So I could just say x can't be positive or negative 3. I could do that plus or minus, or I could just list them out, 3 and negative 3. Okay? So there's my restrictions for the first one. Now let's look at the next one. 2 times 5 minus n over negative m squared times n plus 3. So this one's interesting because the top is already factored. Do you guys agree with that? Top's already factored. What about the bottom? Is there any further factoring I could do in the bottom? No. Okay. We've already got it. M squared times n plus 3. It's already multiplying. Okay. So what do I have in the denominator then? Well, I have this negative 1, if I want to think of it that way. I've got m squared, and I've got n plus 3. And none of those can be 0. I can't divide by 0. So I can divide by negative 1 all day long. That's not going to matter. So really, it's like 3 things here. I'll put brackets to exaggerate. I'm dividing by negative 1, which is fine. I'm dividing by m squared, which is fine, except for if m happens to be what number? 0. Because if I put 0 in for m, what happens when you square 0? You still get 0. Okay, so m can be any number except 0, because 0 squared is 0. So that's m. What about n? See, I'm putting it below instead of sideways here. N can be any number except negative 3. So those are my restrictions on the denominator. Okay, and all we're worried about here is figuring out restrictions. So there's 2 restrictions there. And then our last one. So looking in the numerator, no factoring can be done. It's just one term. How about the bottom? Is there any factoring I could do in the denominator?
Could you collect like terms?
Common factoring, yes. Right? They're not like, but they both have an A in them, right? So the smallest exponent on A is 3. And they both have a B in them. And the smallest exponent on B is 1. So there's my common factor, A cubed B. So if I divide mentally this first chunk by A cubed B, A to the 4th divided by A cubed is A, and B divided by B is 1. So I don't need to show anything there. Good. Minus A cubed B squared divided by A cubed B. Well, A cubed divided by A cubed is 1. B squared divided by B is what? B? Whoops! No, please don't have broken. No, we didn't, guys. Okay. So there we are, factored. So thinking this through means that I have to think through that my denominator is really made up of 3 things multiplying together. A cubed, thank you. A cubed, B, and A minus B. So those are my 3 unknown numbers that are multiplying together. Okay? A cubed, B, and A minus B. Okay? So let's look at A cubed first. A could be any number except 0. Because if I cube 0, I'm still going to get 0. Let's look at this B here second. I could divide by B as long as it's any number except 0. Okay, so I've taken care of that and that. How about A minus B? That one's weird. So we do one of our little grade 9 things. How does A minus B get to be 0? Well, I can either get A by itself or B by itself. And because A is positive, it looks easier to get A by itself. And I would do that by adding B to both sides. So it says that A minus B is 0 if A equals B. Does that make sense? Because if you were to replace A with B, you'd get B minus B, which is 0. Okay? So we just proved that you can divide by A minus B as long as A and B aren't the exact same number, which makes sense. How do you write that down, though? You say A can't be B. Okay? And you need 1 restriction per factor in the denominator. So A can't be 0 takes care of this one. B can't be 0 takes care of that one. And A can't be B takes care of that one. Okay? All right. So how is a rational expression different from a rational function? So let's kind of just do a chart here. Rational expression on this side, rational function on this side. How are they different? Rational functions, just functions of x. Rational expressions can have many variables. Rational functions have a domain to go with a graph. Rational expressions just have restrictions on the variables, restrictions only, okay? Rational functions start with f at x equals, or y equals, etc. And expressions do not. They're just expressions. And those are the major differences. And that's kind of what we noticed when we first looked at the new ones we saw today. All right, so for people that like steps, here are the steps for simplifying rational expressions. So if you like to have steps, you can have this out every time you're trying a question like this. So you do them in order. So first you factor the numerator and denominator as much as possible. Second step, determine appropriate restrictions on the variables that are in the denominator only, because we only care about dividing by 0, or avoiding that. Divide out like factors, or simplified factors that divide to -1 using our identity, where appropriate. And then state your final answer in lowest terms with your restrictions. Okay, so you state them once when you factor the denominator, but then you also have to put them with your final answer. Right? Okay, so keeping our steps in mind, simplify each rational expression, restrictions must be included. First one. Okay, step 1 again, factor numerator and denominator as much as possible. So I'm going to give you a little bit of time to try that. Especially if factoring felt really strange yesterday. Hopefully you're starting to catch on. You got your flowchart to help you. Okay, does anyone think they've got the numerator of a factor? Numerator, Molly?
X plus 2.
Yep.
X minus 2.
Good. So you knew it was a difference of squares. Okay. Anyone need any further instructions on how to factor the numerator? Okay, Jerry, do you have the denominator?
Yeah, it would be x minus 2, x minus 3.
Good. So you realized it was a simple trinomial, and you needed two numbers that multiplied to positive 6 and added to negative 5. If they multiplied to a positive and added to a negative, Darius knew they both had to be negative. Okay? Correct. So the first step is done. We factored the numerator and denominator as much as possible. All right, now see if you can do the second step and figure out the restrictions on the variable in the denominator. There's only one variable, so that's a little easier for us. And we've got two factors that help us decide what x can't be. Anyone think they know the restricted values? Jack?
X can't be equal to 3 and 2.
Yep, 3 or 2. How many people got 2 and 3 or 3 and 2? Nice. Okay. Third step, divide out any like factors. Are there like factors in the numerator and denominator? X minus 2s. Okay, so we're left with x plus 2 over x minus 3, as long as x doesn't equal 3 or 2. Perfect. Next one. Still only one variable, so that's good. Factor the numerator and denominator. So I'll give you some time. To do that, I'm just going to pause this really just for a few minutes. Does anybody think they've got a numerator factor? Sebastian.
C positive, C plus 1, C minus 6.
Yes. Very good. How many people had C plus 1 and C minus 6? Awesome. Doesn't matter which order, right? You could have C minus 6 and then C plus 1 and still be right. Okay. The bottom's a little trickier. What do we do in the bottom? Any ideas? Yep, Owen? Common factor, 7 out. And what are you going to get?
You get 7 bracket 1 minus c squared.
Yes. Is that fully factored? What can you do, Owen?
You can do difference squares.
You can. And what's that going to give you?
7, 1 minus c plus.
Good. And that order matters, right? Because it starts with a 1, you have to have a 1 at the start of each bracket and a c at the end of each. Okay? Now that you've got it fully factored, see if you can figure out restrictions. So look at your denominator. You can't divide by 0, so dividing by 7 is fine, always. Dividing by 1 minus c is fine, unless c happens to be? Yep. 1, because 1 minus 1 is 0, or negative 1, because 1 plus negative 1 is 0. You could use plus or minus 1, it's fine as well. Okay, so c plus 1 and 1 plus c. You got to know in your heart that those are exactly the same. Why are they exactly the same and I don't have to do any identity? Anyone know why they're exactly the same? Yep.
Because of addition and the order and consuming.
They're both positive and the order doesn't matter, right? So you could do c plus 1, 1 plus c, same thing. Okay? So these are the same. Okay? And I can divide them out. And then I'm left with c minus 6 over 7 times 1 minus c. And then I restate my restrictions. And then I'm done the question. Okay? You might want to star this one because of that. You have to know that these are the same. Okay? It's because both 1s are positive and both c's are positive. So it doesn't matter which order they're in. The signs are not off. Okay? All right. Give you time to try the factoring for. Anyone think they've got the numerator factor? Here it is.
E plus 7 and E minus 6.
E plus 7 and E minus 3. Hands up. You got that? Excellent. So simple trinomial. Good. And how about the denominator? Okay.
2 bracket e squared minus 9.
Good. Okay, so that was a common factor of 2. Is it fully factored? No, because what's inside the brackets is a difference of squares. So if you go one step further, what would you have in the bottom, Darius?
You press 2, bracket b minus 3, and then bracket b plus 3.
Good. Okay, so to get fully factored, that's what you need, 3 steps. Okay, 2 steps for the denominator. So once you're fully factored, and before you reduce is when you want to restrict your denominator. Okay? So denominator only, 2 doesn't bother us at all. B minus 3 is okay unless B happens to be 3. And B plus 3 would be fine unless B happens to be negative 3. So my restricted values are that B can't be positive or negative 3. Okay? Now you can look for any like factors in the numerator and denominator because they'll divide to give you 1. So the B minus 3's divide out. Okay? It's always fun to cross stuff off. And then we're left with B plus 7 in the numerator and 2 times B plus 3 in the denominator, as well as my restrictions that B can't be positive or negative 3. Okay? Right, so we're following those 4 steps again. So on to D. Remember when there's a leading negative, it's always part of your common factor, or you always common factor first, second. Okay? Pause it again. Common factor of negative 5y squared in the numerator. How many people common factor that? Okay. And then in your bracket, you're going to get 2y, and this is the part people forget, negative 5y squared divided by itself is 1 plus 1. So that plus 1, a lot of people forget that. They just put 2y there accidentally. Okay? The bottom, I saw lots of people fighting with it, realizing it was a complex trinomial. Okay, so they had their 14y squared, and then they were trying to figure out the 2 terms that added to 15y, and it turns out it's the 1 times table, which is the forgotten times table. Okay, so then 2y squared, I know 2 goes into 14, plus 1y plus 7, and then it just takes 3 steps to factor a complex trinomial. And you factor it by grouping on your second step. So in common with just the first 2 terms is going to be 2y. Then the sign that comes next, this positive, goes next. In common with the second 2 terms is just 1. 1y divided by 1 is y. 7 divided by 1 is 7. If you do everything right, you end up with the common binomials, which we did. And so y plus 7 is your common binomial, and the leftovers, 2y plus 1, form your other factor. So all those steps just took me to step 1, fully factor the numerator and denominator. Okay? So now you have to figure out your restricted values. You've got an easy bracket and a harder bracket. So the y plus 7 is pretty easy to figure out the restricted value. 2y plus 1 is a bit harder. So y can't be negative 7. That one's easy. How do I figure out the 2y plus 1 if I just don't know it in my head? What do I do? So, yeah, grade 9 equation, set it equal to 0. So 2y plus 1 equals 0. Subtract 1 on both sides. Divide by 2. So 2y plus 1 equals 0 when y is negative 1/2. So I add negative 1/2 to my restricted values. Okay? So now I've done all the factoring and I've done the restricted values. Now I can divide out like factors. So those are my 2y plus 1 slashed. So my final answer is going to be negative 5y squared over y plus 7, as long as y can equal negative 7 or negative 1/2. Okay, and it is break. Thank you. Good. Okay, that works out better. Thank you. No. Our break is at, when is it? 10:13. Okay, maybe we'll get done the lesson by then on the break. I don't know. No, we shouldn't do that. We shouldn't have to. All right, does this one make sense to everybody? Yes, good? Okay. All right, so I'm just going to pause it for the factoring for this one. Be careful. No, you got a question? It's a simple trinomial, but instead of just having an x at the start of each bracket, there's an x at the start of each bracket and a y at the end of each. And then you need two numbers that multiply to negative 6 and add to 1. Okay, product is less. All right, so I see people factored out 4. So that was their first step for the numerator. What about the denominator? Get to the denominator. Actually, a simple trinomial in disguise. So if you're going through your flowchart, is there a common factor amongst all 3 terms? No. Count the terms, there's 3. There's a 1 in front of the x squared. Everyone agree with that? Which makes it a simple trinomial, which means it's only going to take 1 step to factor, even though it's got the x, y, and the y squared. Okay, all that means is that not only will your factors have an x at the start of each bracket, they'll also have a y at the end of each. Okay? And then you still need the 2 numbers that multiply to negative 6 and add to positive 1. So then you start listing them out. Bigger one has to be positive, so that's going to be negative 1 and positive 6. Does that add up to positive 1? No. Negative 2 and positive 3, does that add up to positive 1? Yes. So it's x minus 2y and x plus 3y. Okay? But, am I fully factored yet? No, because in the numerator, there's still a difference of squares in there. So x squared minus 4y squared factors to give us x plus 2y times x minus 2y. Now it's fully factored. So step 1 is fully factor the numerator and the denominator. Okay? Step 2, figure out any restricted values for the denominator. So this is the part that is trickier. I'm going to write it over the side here, okay? And then I'm going to erase it. So you have more room than me to write smaller, but you also might want a piece of paper to keep in your notes and help you. All right, so we're going to do our little grade 9 equations until we convince ourselves, and then by the end of today or tomorrow, we might be able to see them in our head. But what would it take for x minus 2y equals 0? So I always write that down, that little grade 9 equation, okay, because I know that I don't want it to end up being 0. And then, because there's 2 variables, it's up to me which one I isolate, okay? So I always pick the easier one to isolate. I think grade 10 substitution, there was always an easier equation and a harder one. So in this one, it's easier to get x by itself because it doesn't have a negative 2 in front of it. Everyone agree with that? So to get x by itself, all I need to do is add 2y to both sides. Okay? So this tells me that for this factor, x minus 2y to be 0, x would have to equal 2y. But that also makes common sense. Because if x were 2y, I'd have 2y minus 2y here, which would be 0. Okay? So if you ignore the y, you'd say, well, x can't be 2 if the y wasn't there, right? But with the y there, all you say is x can't be 2y. Okay, so x can't be 2y is one of our restricted values. So if you apply the same reasoning to x plus 3y, what can x not equal for that factor? Negative 3y. So if there was no y here, I'd just say x couldn't be negative 3, so it can't be negative 3y. Because negative 3y plus 3y would be 0. Okay? I'm just going to erase this part. So I'm going to go to our next question. It's not in the way. And I'm going to put the negative 3y down here. All right, so we've done our factoring. We've done our restricted values. Now we can divide out any like factors. Are there any? Yes. Any others? No. So now we go to our final answer. So what's left on the top is 4 times x plus 2y. On the bottom, x plus 3y, along with my restricted values, where x can't be 2y or negative 3y. Okay, f. Well, f's a tricky one. It's okay though, we can do it. This is a complex trinomial, you're aware. Right, I'll give you some time to think about it. So I got lots of people common factor negative 3c in the numerator. Okay, remember the leading negative is a hint that you got a common factor. At least that might be the only thing you have to do, but you have to do it. Okay. And then negative 3c squared divided by negative 3c is positive c. Positive 6cd divided by negative 3c is negative 2d. Okay? Denominator, complex trinomial. There's no common factor amongst all 3 terms. Count the terms. There's 3. It's complex because there's a 3 in front of the c squared, in this case, term. So if you multiply those 2 terms together, you get 6c squared d squared. And you want to add up to negative 7cd. So to multiply to a positive and add to a negative, both have to be negative. Okay, and as I walked around, tons of people had them both being negative. Great. So they had negative 1cd and negative 6cd. Correct. Okay. So then you're going to write out your 3c squared. And then lots of people knew that 3 went into 6, so they put the negative 6cd after that. Then the negative 1cd, and then the plus 2d squared. So that's our decomposition step, where we break down negative 7cd into negative 6cd minus 1cd. Okay? Remember, it's 3 steps to factor one of these. In the second step, we factor by grouping. So we factor the first 2 using common factoring, and then the second 2 using common factoring. Okay? So what's in common with the first 2 terms is 3, and because there's a c in both of them, c. And then when you divide 3c squared divided by 3c, you get c. And when you divide negative 6cd divided by 3c, you get negative 2d. Okay? Then the sign that comes next, this negative sign, goes next. And then we're looking at what's in common with 1cd and 2d. So it's going to be 1d, because there's a d in both of them. Okay? So this negative sign is hooked on here. It's part of what I'm dividing by. So when I divide negative 1cd by negative 1d, all I'm left with is c. Okay? And when I divide positive 2d squared by negative 1d, I get negative 2d. So that's how you get these guys to match, which is what you want, because that's your third step, is to factor out that common binomial. So if you do the grouping right, these 2 brackets or binomials should be the same, and they are. You've got c minus 2d in both of them. And then the other factor is 3c minus d. So it took me all those steps just to do the first step in the link, which is to fully factor the numerator and the denominator. Okay? The second step is to figure out the restricted values. So see if you can think through what they would be. So we've got two factors in the bottom, and we need one restriction per factor. Okay? So from the yellow factor, I need to say something can't equal something, and from the green factor, I have to say something can't equal something. I need two restrictions. Darius, you got one of them?
C can't equal 2D.
C can't equal 2D. So this one's set up like C minus 2, but there's D on the end. Okay, so C can't be 2D. That one's the easier one. This one's harder to see. Did you see one for that, Darius?
Yeah, C also can't equal 1D.
C can't equal 1D. So if I let C be 1D, I would get 3D minus D, which is 2D, and that would be okay. Jacob? D can't equal close, not negative 3C, because if D was negative 3C, 3C minus negative 3C would be 6C. Okay, you did C.
Yes, C can't equal D over 3.
You're correct. Okay, so I'm going to show both. I'm going to show it one if you've got D by itself and one if you've got C by itself. So if you're looking at this, okay, which hopefully you did, set this equal to 0 if you don't know what it is. What's easier to get by itself? Adriana decided C was, probably because it has a positive in front of it. Okay? So she added D to both sides. And then she wanted to get C by itself, so she divided both sides by 3. So she got that C can't be D over 3. Okay? If you look back a step, so if Adrian is perfectly right, and that is a perfectly right restriction. But if you look at this step here, 3C equals D, this is what Jacob was doing really, okay? It's also the same as D equals 3C, and you can just say D can't equal 3C. It would have also been the same thing. So these two restrictions are the same, and you only need one of them, okay? So you could either say C can't be D over 3 or D can't be 3C. They're the same thing. Your choice of which one you want to write, not both of them. Because that would be redundant. Do you know what redundant means? You say the same thing twice. You know, okay, so you only need one restriction per factor. Okay? So remember, always make that little grade 9 equation and choose to get one of the two variables by itself if you can't just look and see what it is. Okay? And some people are good at seeing that, and other people need to write it down. Other people write it down for the first few days of a unit, and then they get used to it. But we don't have that luxury of having the unit for a couple of days, really. We're doing like a crash course here. So. All right, G. X minus 1, can that be factored? If it was x squared minus 1, it could be, but it's not, right? It's just x minus 1, so no common factor, it's not a difference of squares, can't be factored. What about 1 minus x squared? Could that be factored? Is 1 a perfect square? Yes, so it is a difference of squares. All right, so I've fully factored. Now I want to do my restricted values on the denominator. There's 2 factors in the denominator. So for the yellow factor, x can't be check. 1, and for the green factor, -1, so plus or minus 1. Okay, everybody good there? Now I want to be able to divide those out, but they have opposite signs. Here the x is positive, here the x is negative. Here the 1 is negative, here the 1 is positive. Okay, so So this is where I can use my identity. B minus A equals negative A minus B. Okay? To rewrite either the x minus 1 or the 1 minus x. Okay? So I always feel like the B minus A looks like the 1 minus x, so I always do it to that one, but other people are more flexible. I'm going to change that one. So now these x minus 1's divide out. Leaving me with what on the top? I cancel something out of the top. What is the left there? -1, good. So the 1, and then I bump up the negative, because when I have a choice of where to write it, I always like to write it with the numerator. Okay? And then in the denominator, I have 1 plus x, and then I have to rewrite my restrictions. Okay? All right, the next one. Common factoring in the numerator and a simple trinomial. Okay, so the numerator, everyone, as I walked around, had 3x times x minus 5y, which was lovely. Okay, common factoring, awesome. I said the bottom is a simple trinomial, so I had lots of people that had their 2 brackets set up, which was great. They had an x at the start of each. And because of the y squared, they had a y at the end of each, which was awesome. Okay? And then you needed the 2 numbers that multiplied to give you a positive 10 and added to a negative 7. So if you're multiplying to a positive and adding to a negative, the only way that's possible is if both are negative. Okay? So you could try -1 and -10, but that doesn't add up to -7. -2 and -5 does. So it'll be x minus 2y and x minus 5y. Okay? So that's fully factored now. So now you're at the stage where you want to write your restricted values down. So see if you can figure out what they would be. So there's going to be 2, 1 for each factor that's in the denominator. There you go. Yep, what are they?
X equals 5y and 2y.
Yes. Any questions about those? Those are like the easiest 2 variable ones where it's set up. Like if you just ignore this, you'd say x can't be 2, so x can't be 2y. X can't be 5, so x can't be 5y. Everyone see that? Okay, awesome. So now I'm going to divide out any like factors. And then restate my restrictions. And then I'm done that one. Okay, we're getting there. 2 more to go. So for I would check to see if there was a common factor. There's not. 2 terms, is it a difference of squares? No. So the top of this one can't be factored. So recognize that that's a possibility. You may get something that can't be factored from time to time. Okay? In the denominator, check for a common factor first. Is there something common? Yep. 4 and n. Okay, I agree. 4n. So 4 goes into 12 and 20, and it's the biggest thing that goes into both of them, and there's an n in both. So 12mn divided by 4n is 3m. Do you agree? Minus 20n squared divided by 4n is 5n. Okay, so now we're fully factored. So now we are looking at our restrictions. So the 4 doesn't matter. 4 is never going to change. And then we've got n which can take on different values, and then we've got this factor 3m minus 5n. So the only ones we need restrictions for are the n and the 3m minus 5. And dividing by 4 is always fine. Anyone think they got the restriction? Darius?
I don't know when this is right, but correct, but M, doesn't equal 5.
Yes. Good. Okay, so that's the blue one. So Darius would have done 3m minus 5m, the Great-Mann equation equals 0. And then he decided to get m by itself. So add 5n to both sides. And then you still don't have m by itself, and you can divide by 3. So that's where he got m can't be 5n over 3. Okay? How about this n here? N can't equal 0. Good. It would be anything except 0 because we're dividing by n. Okay? Nice. All right. J. Fully factor, numerator and denominator. Okay, let's people puzzled by what type of factoring the top is. Okay, so the first thing you check for is a common factor, and everyone's decided there isn't one. Now you count the terms, there's 2. And then your flowchart says if there's 2 terms, you ask yourself the next question, which is it a difference of squares? Is it a difference of squares? Can I take the square root of 9m squared? Yep, 3m. Can I take the square root of 16n squared? 4n. And is it a difference? So it's a difference of squares. Okay? So the top is going to be 3m minus 4n times 3m plus 4n. So the flowchart really comes in handy if you're not sure where to start because it tells you where to start. It tells you what to do. Check for common factors. If there isn't any, or even if there is, next up, count the terms. If there's 2 terms, either it's a difference of squares or it can't be factored, so it tells you what to look for. Okay? This is important. All right, the bottom, check for common factors first. Is there a common factor? 2m squared, very good. Okay, good. So then you're going to divide each part by 2m squared. So that's going to give me 4n minus 3m. Agreed? I just want to back up over here. We didn't talk about why this was the final answer. I just kind of knew it was in my mind, but we didn't talk about it. Okay, why is this the final answer? Why can't I reduce anything in I? I can't use that identity because the M is with the 3 here, right? And up here, the M is with the 5. So they're actually totally different. Does everyone see that? It's trying to trick you into thinking you could use that identity, but you can't. Because they don't just differ by a negative sign, they differ by the numbers that are with the M and the numbers that are with the N. Okay? So this is as low as it goes. Sorry, back to this one. All right, so the next thing you want to do is get your restrictions. And they're going to come from the M squared and from the bracket 4n minus 3m. So you need 2 restrictions, one for the M squared and one for the 4n minus 3m. Okay, so I can divide by m squared all day as long as m's not 0. How about 4n minus 3m? Anyone get a restriction for that one? Curious? N can't equal 3n over 4. How many people put that one down? Yes! Yes! Good, good. Or you could have had n can't equal 4n over 3. Okay, if you decide to get n by itself. And is there anything I can divide out here? Yes. Identity, right? If I do the identity, the 4n's have opposite signs and the 3m's have opposite signs. So I can change the top to negative bracket 4n minus 3m and leave the bottom the same. And then I can divide out these ones. They're now the same because I used the identity. So now in the numerator, I'm left with negative bracket 3m plus 4n. The bottom, I just have 2m squared left. And my restrictions, that m can't be 0 or 3m over 4. Okay? All right. I think we're at break, and we will finish the last question. Yep.
Wouldn't the n be put into 3 and 4, not m?
Oh my God. Thank you. Let's change that there. N can't equal 3. Comma. Okay, and I was trying to pause this. There we go. All right. Shelley simplifies a rational expression, and this ends up being her answer. We did one kind of like this yesterday. What could the original rational expression have been? Okay. So the hint for these reverse questions is that the restrictions come from the denominator. So this restriction that x can't be negative 2 comes from here, the denominator. But if there's also the restriction that x can't be 5, what also must be in the denominator? Yep. A negative 5, not just a negative 5, x minus 5. Does that make sense? And if there's an x minus 5 in the numerator, but this was my answer, there also must have been an x minus 5 to cancel it with in the numerator. Does that make sense? Because they're not showing in the answer, there must have been 1 on the top and 1 at the bottom so that they could divide out to give you 1. Okay? And then, so that is how you reason it through. That 5 is going to go with that. You needed to add that in the denominator, but because it wasn't in the answer, there must have been 1 in the numerator, so that really they would divide it. Okay? And then usually when they ask what the question looked like, you have to make it look like one of these guys, where it just starts off with a polynomial on top and a polynomial on the bottom. So that helps us practice our FOIL or double distributive property, whatever you called it in grade 10. X times 3x is 3x squared. X times negative 1 is negative 1x. Negative 5 times 3x is negative 15x. And negative 5 times negative 1 is positive 5. And in the bottom, same idea, x times x is x squared. X times positive 2 is positive 2x. Negative 5 times x is negative 5x. Negative 5 times positive 2 is negative 10. And then you can just go one step further by combining the like terms that are in the top and bottom. The top can be simplified to 3x squared minus 16x plus 5. And the bottom can be simplified to x squared minus 3x minus 10. So that's what the question would look like if that was the answer. Okay? That's what the question would be if that ended up being your answer. Okay? Alright, so I have a practice for you. I will post solutions shortly. Oh, I'm just gonna stop this.